Hey, CHEM 2P21, Ian Gordon here, Science Librarian, to help you with this information exercise. This is the SciFinder section, so a short demonstration of how to use it for this, but it can be used for other things as well. Here's our homepage and Omni and all those sorts of things. You can get to SciFinder any other way, by listed databases. The research guides is probably the best thing, then the chemistry guide is the best thing. And then go to the CHEM 2P21 page. And so this video is archived here. Other sorts of things you need for this assignment. But you really want to go to chemical properties, patent. This thesis, SciFinder indexes a lot of those things, but I go to the articles tab and pull up the SciFinder page. But before we do that, here's the questions you need to answer. First one is you need to complete the following for a small chemical antibiotic drug of choice from that list that's on the form. I picked amoxicillin, which is not one of yours, but it works the same way. Molecular formula, which you can almost get anywhere, including SciFinder. CAS registry number is like a social insurance number that you have for a specific chemical. And if there's one thing SciFinder and American Chemical Society, or CAS, does, is they keep on top of these sorts of numbers. Improve them, change them, but there's a number for almost everything. Of the 20 million compounds in SciFinder, there's always a chemical abstract or CAS registry number. Remember that only 10,000 of those sorts of chemical compounds are used on a regular basis in a commercial or common sense way. Most of them are paper documents, theoretical. As you can understand in looking at the structure of amoxicillin here, there's a billion sorts of permutations and computations for chemical structures. But they try to keep on top of the most popular ones. And that's a big thing that they do, because not only does CIS and SciFinder need that, other databases use that information as well. The IUPAC name it's a standardized organization that names that structure. I certainly couldn't do it. Different way of naming sequences and try to find the one that's most appropriate. Most databases have this or other ones, and you just need to affirm what it is, because someone may ask you, so what is the real name using chemical structuring, sequencing classifications for this particular compound? PubChem CID, chemical identification number, it's a number you can go to PubChem and find. And Reaxis, you'll see this number, so you need to fill this in here as well. And it says insert an image of the drug, chemical structure, and name the source. So I went to Sigma Aldrich, there's 30 or 40 or 50 sources, and just screen captured that structure. It looked good. Two-dimension works well. Pretty fascinating, but a lot of people depend on this for their lives. So that's how you, question number one is pretty easy, but you need SciFinder to do this. Question number 4 deals with SciFinder. It says go to the database, and we'll do that in a minute. If you haven't got a username and access, you need to register for one. I'll show you how to get that. Or if you forgot your password, you need to go there as well. So to ask the questions using the database, how many reactions, searching this as a product, meaning how many reactions, so we're speaking the language of the databases. Omni, Google Scholar, other databases don't have reactions in them that are functional and included. So whenever an article or a patent or a document comes to SciFinder, they index it by its standard words and classification to describe it. The abstract, the title, the author's keyword, but they actually add indexing to it. So the proper names, the chemical compounds. No, they don't identify every compound and every reaction for every document. There'd be billions of them, but they have an editorial license to say these are the key reactions, these are the key substances, and this is what helps to identify not only this article or this patent, but it helps you to derive a search strategy to be informed in case you wanted to know what reactions, what's the yield, how many steps, what are the catalysts, how old is it, that you would use to learn from. Because in chemistry, like other areas, you try not to reproduce what somebody else has done, and you learn from other people's as well. Next question, how many retrieved references were used, limiting to preparation? So you can search the literature using words. So that's what it's done. So only 86 reactions, but 2,024 articles that talk about it. Their license. Reload, and I'll show you what that means. How many references when you limit your search to biological studies? And so there's all sorts of permutations and computations of way you could search for the literature, depending on what you're looking for. Only you know when you have too much, too little, and when to adjust your search strategies so you can be successful. how many of these references were patents is, and so we'll do that. So about 10% of those documents were patents. That's a lot of patents, a lot of original ideas that have been codified by standards or trademarks or patents. Select one of the most recent patents and cite it like I've done below. This one here is cribbed from my notes, and this is the ACS style to identify what it is as well. Question number 5 says, go back to the SciFinder database and how many references for your drug. So explore by chemical structure, and we'll do this. So no other databases do this, and that's why it's a proprietary database, because a lot of work goes into it. And that's why it's important, because it not only searches by chemical structure, it searches by reaction and compounds. Again, not what normal Omni-like Google Scholar-like databases can. It says, get the references, preparation of biological studies. We want articles, we don't want patents, and we want to refine by chemical abstracts or the chemistry side, and I'll talk about that, and things that are in English, and then we just need a number. So it's pretty easy there as well. So those are the two questions, the 3 questions that you need to know. Let's go now jump into SciFinder. So here's our homepage, our research guides. Chemistry is where we need to be. Here's the CHEM 2P21 chart, and this is the video that you're looking at now, the SciFinder one as well. So we want to go to articles, and there's lots of articles, databases that you can search. Many of them serve different purposes, though they overlap. Some are common, some include all the articles, and then these are the new ones that you should try as well. They're the open ones that you could use. But we want to look for in SciFinder. So if you need to register, you click on here if you've never used it before, and it asks you to register and move through that process, so that's not too difficult. Then it'll email you, ask you to validate and verify, and go in and use it as well. As long as you can move through our proxy server, meaning the Brock authentication, your SciFinder account should be good as long as you're here at Brock. If you want to move into, there's other videos that you can look up to find more about it. Register as a first-time user does the same sort of thing as well, but let's jump into SciFinder. It asks you to join. I've already signed in, so it asks you for your username and password. I just have it live all the time. There's a sign out. It asks you how you want to search. So I'll just move this over a bit here. So you can search a number of different ways. So here's the exploration. You can search by reference topic, which is the default, meaning you put in words. It's like a Google-like interface. So you can put amoxicillin preparation. You may get things. And you may find the answer that you're looking for. But again, being a chemistry tool allows you to search for things in different ways. You can search by authors, by company name, document identifier like DOIs or other numbered citation tools, a journal, a patent, a tag record, meaning you could add tags to these records that are yours as well because it's your account and that you use it. Marcouche is looking for patents, so they're generic structures because you have to speak like a patent does. That's kind of weird. Molecular property, a property, meaning looking for spectra or a solvency, or pH, or log P's, or things like that as well. Chemical structure, we won't go there now, but substance identifier. So this is how you search. So you can put in examples that are here, and I'm going to put in amoxicillin. Spelling does count. If it's not there, it'll give you 0. So you're kind of going, am I doing this right or whatever? So I know amoxicillin is here because I've tested it, and it gives you 1 entry. It's like an encyclopedic dictionary for this particular chemical. If you look at it and click on the number, this is the CAS registry number for it, so you cut and paste that in. This isn't the IUPAC nomenclature here. I know this one is, this one here, but you'll see that in other databases like Reactions that'll give you that information as well. Molecular formula using the Hill system, meaning how they sort the elements and the numbers. And again, the structure that's here. And it's a dynamic database such that you could click on this and search by, or you can get commercial sources for this. SciFinder N is the next database version, so it's the next upgrade. We will get that one day, but not today. So it's saying, how do you want to search? Well, here's a SAS register. Let's a few more. So for this particular encyclopedic record, here's all the other names, including trade names, common names. Look at all the names for amoxicillin. And then all, like a dictionary, these are like subfields of different information. We won't go here, but it gives you the spectra. And you can search for these in a dynamic way as well. So it says for the first question is CAS number, IUPAC structure. You can even cut and paste this or export this as and quote it as SciFinder as your source to answer question number 1. The next question is, it says, let's search this. So you've got this, and let's go back. The nice thing, it gives you breadcrumbs here, so you can always go back to where you were before. And that's always good. Sometimes you can have to start all over again to try another topic, or go at it a different way, knowing you can go for reactions, references, or combine, or go by a structure search as well. So there's different ways to tackle this database to getting the answers that you want as well. So it says how many references are for this particular compounds. Dealing with, and you can check all the substances that are listed. Maybe there's more than one compound there. We want to find preparation. So it's asking us, and we must be safe to say that preparation, we understand what that means, and when it's lying and when it's working, or when it misses things. And it found that there are 2,024 records that you could sort any particular way, remove the duplicates. Here's the sorting feature here. You can sort by author, titles, publication years, go up or down, meaning old to new or high to low. And you can go through all these at any time. But behind each one of these citations is a full abstract and a full record. Then it links to the full record in our library. And for SciFinder, if you find something, we have all the patents because they're all on open source. But we have 80 to 90% of the journal articles that are listed here as well. So it's begging you, 2,024 is too many. But then the next question asks you for how many references for the preparation for this particular compound. So we asked, and I'll go back over it again, we've got amoxicillin. How many reactions for the product? So that was the first question. 86 is the number you write in. So you can actually go through these, and behind every reaction there's a source for it. And you can click on it, know more about it, and then get the article and read about it, knowing that there's a selective number of reactions selected for each article and patent as well. Let's backtrack again, or start all over. And then we got references. That was the answer to the next question is, then we said, let's get references for this biological study, however they define that, and we'll find out how many are there, so we'll get those. Then we say, well, there's other topics, so you could refine this at any time. So you can refine it, meaning you're looking to see what's there, or you can analyze it. And you can analyze by any one of these variables. A document type, journal name, publication year, sort, or you could refine by any one of these particular topics as well. So the question asks you, refined by patent, so we want to look at refined by document type. When you click on the feature here, and we just want patents as opposed to journal articles, and refine it does sequencing for you. So I found out there's 2,881. It's a relational database, so it keeps changing. So the number changes every day. Not too fast, but it does change every day. So that's the number you would put in for that section as well. Then you need to find which one of these things, and you can sort them to high and low by number, or you can just browse them as well. So find one that's of relevance, or you can, what you can do is sometimes you can analyze or refine by research topic. So you can actually put a word in here, like, well, let's put in the word cancer. If that's the term you want to use. So it takes that set. So you're refining this even further. The most common refinements are by document type and by language, English, meaning it gives you a better guarantee that it's here as well. But yet you want to sort for things that are new to old, which is here, or sort by relevancy as well. So if you find one, you click on it. This patent pack, where is it here? No, it's not here. You can get the article here, but for patents, they aren't in our library. You can link to them or find them, but then you take this and it tells you all the information on the right-hand side of what it is. It gives you all the concepts or standardized language. Look how many compounds are part of this particular patent. Structure, preparation, information about it. Wow, whoever put this document together must be really good. So what it can do is you need to cite this using ACS style. Now, nowhere here in SciRef, maybe one day, you can click on it, says cite it in APA or MLA or Travian or at ACS. What I would do, if it's an article, you click on the DOI and put that into. You can't take the patent number, but you can actually click on here. And let's go to that patent. Sometimes it works. We don't have patent pack in our library, so we don't got to use that. We don't have this, but link to other sources. This is where you'd find if it's a journal article, whether it's in our library or not. ESPASnet is the European Patent Office, and it has every patent in the world. It's just amazing. So sometimes it connects, sometimes it doesn't. So it goes to their database. I found nothing, but we'll show you how that works. So you can actually go to their advanced search and put in the number or put in the title of it and find it as well. Or you can just go to the Google Internet and take this patent. And and cut and paste it. Go to a SPASnet, put it in as a title, and you can actually look at the full patent here. So SciFinder is kind of not good for that, but it gives you all the information you need to know. The title of the author, take the example, and put this into ACS citation with title, so you need the title here, and then put that in to answer the next question. So let's go back to Explorer. Research topic, keywords, substance identifier, we found that as well. But let's search this another way. You can search by chemical structure, so you can actually go to the chemical structure database and click on it and edit and create and draw your own structure. But I'm not a good drawer. ChemDraw would work for this, or you can import and export. But let's go back to substances. And if you see here, you can actually click here. So there's more than one way to do this. You can explore by chemical structure. What it does, it takes in this database the chemical structure, puts it in here. You could click on it. And here it is. So you could say, I want substitution here, here, here. I want an R group here or an X group here. I want no substitution on these rings. And so you can make it as big or as open to question, depending upon the data and the number of structures and reactions that are in the database as well. This is really powerful. Synthetic organic chemist allows you to think and draw and speak the language of the database. So this particular question says we want to search it as an exact search, meaning this compound, don't want any more or any less. You could freeze something on it as a structure, and we click on OK. So it goes back into the database. It searches through that algorithm using structures, and it found a number of tools as well. So let's search now. And it searches for references being patents or articles as well. So here it says on the right-hand side a number of things. We want to click wherever there's a number. Because it says, do you want salts and stereoisomers? We say yes, so let's get all those substances. So you're searching for substances by structure, and you're getting them as well. So it says, get all the references for all these compounds. They're all there. And we want to get references for biological studies and preparation. I guess you could think for other things as well, but that's what we're looking for as well, for all substances in this set. So let's get. I'd found 37,000, so that's a lot of articles. It's searching by structure for this particular compound, but it's a very big compound and a lot of research has been done to it. It says next, look for document type. So we can analyze or refine, but let's refine by document type. And what we want is a journal article as opposed to a patent. And we want to refine, so it takes that set and finds out how many of them are journal articles, which is most of them. Then it says, let's search by database. So let's refine by database. And the neat thing about database here, the neat thing about this particular SciFinder is it includes all the records from Medline or PubMed. So you can search in both those databases simultaneously. Now in Medline, you're searching for their mesh headings, and there's no structures in Medline, and their words and the keywords and abstracts, but they say carcinoma as opposed to chemistry. So there's different languages, and so it allows you the flexibility of both. When you set up your SciFinder account, it allows your preferences to see one record if they're both in each database, or both of them. So it's a preference that you choose to use. But we want to look at the chemistry side. So let's just look at chemistry and exclude everything from Medline. And the last question we want to ask is, well, it does the citation. It usually works for us. It's refined by language. Chinese was first. Isn't that amazing? Eh? English. And so at the end of this search strategy, this is the number you need to put in. So 17,019 journal articles or biological studies that deal with preparation in the chemical side of SciFinder that deal with this structure or equivalence for this particular compound are there. So you may even want to narrow this down further. But this is how you do the SciFinder exercise. Good luck with your topics. But remember, always start with the chemistry page and don't rule out using CHEM 2P21 resources that are listed here. So good luck with your topics and your study and this exercise.